Okay, so our project is on static electricity, and our claim is what materials, when rubbed on a spoon, create the most static electricity and the most attraction between our salt and pepper mixture. First is create a mixture between the salt and pepper. There you go. Okay.
First, we're going to take a spoon, a plastic spoon, and we're going to rub it against the material and then see how the attraction is to the salt and pepper. And if it's attracted to it, the pepper should lift from the mixture onto the spoon and cling onto the back of the spoon. So first, we're going to try 100% cotton. So rub the spoon on it. And then you put it over it.
You know, come a little closer. It's gonna put it.
And as you can see, there's a lot of pepper on it, which means it has a more negative charge. So,
Okay, so let's put that in.
next material.
What do you want to do next?
We'll do Reynolds wrap. So we have aluminum foil. So we'll cut off a piece of this. We're going to rub both sides against it in case one's a little bit more charged than the other. Okay. Okay. There's a little bit of attraction. See, if you can see, there's a little bit of pepper on the bottom of the spoon, but not very much. This shows that there's a much weaker charge on it than the cotton was, because it's not attracting as much. And if this one, there's more likely to just stick on it, where this one can fall off really easily. So, I'll do the polyester next.
Okay. The next material we're going to test is polyester, and this shirt is 100% polyester.
Whoa. I wasn't expecting that to be so fast.
Okay, so that showed that the polyester had even more of a negative charge because the salt and pepper actually plugged up and shot up to the spoon, which displayed that the polyester shirt had more of a negative charge than the other two materials that we've tried so far. And the attraction was pretty strong on that, because even if we tipped the spoon upside down, they still stick to it. Okay.
Added more pepper to it, so it's not too much salt. Because the pepper is lighter than the salt, it's why it attracts to it. So, we need lots of pepper. Is that good? Okay. The next one we're going to be trying is silk. I have a 100% silk dress that we are using. So, rub this all over it. Okay. That one had a somewhat negative charge from it, but it wasn't as powerful as some of the other ones we've seen so far. So, and they could easily fall off if they wanted to, but it works. So,
Balloon.
that's the balloon.
All right, next we're gonna do a balloon.
And we use the balloon because when you when you blow the balloon and put on your hair, it creates the electricity. So these were all materials that we were curious whether or not they would create the static that it needs in order to pick up the pepper. So since the balloon works so well to get static going, I figured it would work here.
Okay, so we had a pretty large attraction between the balloon and the salt and pepper. And as you saw, a lot of the particles flew up to the balloon, which displayed that there was a pretty strong attraction between the balloon and the salt and pepper.
You need to add more or not?
I think it's good.
Seems good. Okay. Next thing that we are going to use is cling wrap. I figured it would work because it clings so well to help prevent foods from going bad. So we were just curious to see if it would work here. Okay, as you can see, this is absolutely nothing. There is no pepper particles on here whatsoever. This shows that this did not have enough negative charge in order to create the static that it needed to for the pepper to lift onto the back of the spoon. So,
We also figured that the spoon and the cling wrap had the exact same charge, so no type of attraction was created there because they were the same charge. And then is this the last one?
yes.
Wool. Okay. And the last material that we have is wool. So we're going to try this. Okay, so as you can see, the wool had the strongest attraction between the salt and the pepper. The salt and pepper particles flew to the wool spoon, which was rubbed with wool. So we figured that the wool has the most negative charge and the most electrons out of all the other materials that we tested. Since the spoon is neutral to begin with initially, each material gives off a certain amount of electrons. And in our experiment, we found that the materials that contain the most electrons and the most negative charge are the materials that sent the most electrons to the spoon, which then created a much stronger charge and more of static electricity between the spoon and the salt and pepper. The cling wrap sent no static electricity and absolutely no charge. Because the spoon and the cling wrap were the exact same, contained the exact same amount of charge. Yep, and the wool had the most because this had the most electrons and the most negative charge. So the materials with less electrons and more of a positive charge create less static electricity and a weaker attraction to the salt and pepper. So even the spoons that do have a small amount of salt and pepper on them, if they're flipped upside down, you can see the particles will drop off because the attraction is so weak. But then with other materials, such as the wool, the spoon particles, or the salt and pepper particles, don't drop off from the spoon because the attraction between the spoon, a negatively charged spoon with the electrons, is stronger than the ones with less attraction.
That's our experiment. Hope you liked it.